Welcome to video number 2 for today. So we are going to take what we did in our last video, which was the product and quotient of complex numbers, and we're basically going to expand that. So if we're trying to multiply more than two things together, to do that we use DeMoivre's theorem. All right. So let's say, for example, that instead of just having z1 times z2, we had z1 times z2 times z3. Okay? Following our idea that we did in this video before, we multiply the moduli together. So if this one has r1, r2, and r3, this would be r1 times r2 times r3. And then we would still go in here and we add our angles. So we'd have cosine of theta 1 plus theta 2 plus theta 3. Oh, that should not be a bracket. And then we have plus I times sine of theta 1 plus theta 2 plus theta 3. So we can keep expanding this idea out. So if we're multiplying, I don't know, like 10 or 20 of these complex numbers together, it's going to keep following this pattern. But what if we're just multiplying the same complex number together multiple times? If this eraser would work for me, that would be fabulous. Nope, it's not going to do that. All right, well, you know, happy Monday. There we go. So if we're multiplying the same complex number together, let's say 3 times again, okay? So we have that same z, that same complex number to the third. Remember, this is the same thing as z times z times z. So these all have the same radius and the same angle. So we could write this as r times r times r times cosine of theta plus theta plus theta plus I times theta plus theta plus theta. Changes the brackets. Well, these are all the same, so we can write this as r to the third. And then if we have theta plus theta plus theta, that's the same thing as 3 times theta. And same thing inside of our sine. Oh, this should be a sine right here. Plus I times sine of 3 theta. Same thing holds if we're raising that power to the 10th, to the 100th, to the billionth, to millionth. So instead of writing all that out, we can just simplify this. So if we have a positive or a complex number z in trig form, and n is a positive integer, then our complex number to that integer raised to that power is equal to r to that power times cosine of n times theta plus I times sine of n theta. So this is really nice when we have complex numbers that are being raised to huge powers. It's going to make our life a lot easier. So for this one here, we want to write this. We're raising this complex number here, z, in trig form, to the 5th power. So following DeMoivre's theorem, we can write this as 3 to the 5th times cosine of 5 times 3 pi over 2 plus I times sine of 5 times 3 pi over 2. So the only thing that is going to be kind of a catch, and not even really a catch, is that on your test for this, it's going to be on Schoology, so it's going to be multiple choice. So you are going to need to simplify this. So 3 to the 5th, what would that be? 243. I have a calculator with me. I didn't do that in my head. I'm not that impressive. Times cosine of, this would be 15 pi over 2 plus I sine of 15 pi over 2. Boom, there you go. So that's DeMoivre's theorem. Now another problem that you might run into is you have your answer in standard form and we want to simplify this down a little bit. So DeMoivre's theorem only applies when we have complex numbers that are in trig form. So we need to get this to trig form. So remember, our typical trig form is r times cosine theta plus I sine theta. Okay, and since we have a plus bi, a is equal to r times cosine theta, and b is equal to r times sine theta. So our a value here is 1/2, and our b value is root 3 over 2. So first thing we want to notice is that these are both unit circle values. So there are angles that give us a cosine of 1/2 and angles that give us a sine of root 3 over 2. So that means, since there's no coefficient here, our radius is equal to 1. So our radius is 1. And then cosine of theta, we are looking for a value of theta that gives us a cosine of 1/2, positive 1/2. And since our sine value is positive, we're going to be looking in quadrant 1. So what angle value gives us a cosine of 1/2 and a sine of root 3 over 2? That would be pi over 3. So we would have 1 as our radius times cosine of pi over 3 plus I times sine of pi over 3. And now this is the same thing as this complex number here. Now remember, we want to raise it to that third power. So we apply DeMoivre's theorem, and we have 1 to the third times cosine of 3 times pi over 3 plus I times sine of 3 times pi over 3. That was sloppy of me, I should have put brackets here. But 1 to the third is just 1, so we're not even going to write that. We really don't even care. Okay, so this now is equal to cosine, these cancel, of pi plus I times sine of pi. Now we can simplify this. We know what cosine and sine of pi are. Cosine of pi is -1, and sine of pi is 0. So this whole thing goes to 0, and this is equal to -1. So if we cube this number here, we get -1. So that's a little bit of a sneak preview into tomorrow's lesson. Tomorrow we will be talking about roots of unity. I know, super thrilling. You guys are going to see this number right here come back. Don't worry. I know I'm kind of leaving you on a cliffhanger, but that should be bringing you back for class tomorrow. For now, work through the homework, and I will see you back here tomorrow.